gasoline direct injection system, the fuel is poured directly into the combustion chamber. Okay, we talked about that a little bit, so, it's not sprayed at the valve, it goes right into the combustion chamber. Usually, most of them are straight down, not all of them, but most of them are straight down. Port fuel injection system is constant fuel pressure, but varied injection pulse width. And direct injection is almost constant injection pulse width with varied fuel pressure. So again, kind of a reversal, right? So we have a pulse that's spraying in the combustion chamber, but we're going to vary the fuel pressure, how much. And that's kind of what we're looking at today. Is we're looking at idle fuel pressure on the high side, and then what is at a raised RPM, so we can kind of see a difference. We can't go test drive them, but we can accelerate the engine a little bit, raise the RPM, and see the difference. A direct injection system sprays high fuel pressure. It says up to 2,900 psi. Can be more depending on the engine and application. So it's a lot more than our 50 to 70 psi that we were looking at last week. Some of the advantages: improved fuel economy, lower emissions, higher compression ratio for higher engine efficiency. Again, because we're spraying the fuel directly into the combustion chamber, we need to raise the compression ratio to help atomize the fuel. We can use lower octane gasoline, and then we get higher volumetric efficiency. So volumetric efficiency is how well are we breathing in the air, and how well are we using the air with the fuel, and then we get a calculation of how much air volume the engine can bring in for its performance. With some of the other sensor chapters, we'll kind of get more into that. Some disadvantages: higher costs due to the high pressure pump and the injectors. Then we have more components compared to fuel injection, and then we can end up with higher NOx emissions. Just because we have the additional, so we already, in the direct injection systems, we have the low pressure fuel pump feeding the high pressure pump. We've always had that, but now we're adding the high pressure pump, which is a cost, and then we have different style injectors, a little more complicated, and have to handle a higher pressure, so there's a higher cost associated with those. So because there is a higher initial cost to the manufacturer, now it's a higher cost when we have to go and repair some of these components. Comparison port fuel injection. So on the left we have our direct injection system, again coming down through the cylinder head, spraying right into the combustion chamber, so our air just comes in here, and then we have our fuel here, and again this is one we just saw, where it sprays right at the back of the intake valve. So this just kind of shows the pump assembly and some of the, so we start out at our tank, we have our inline, our in-tank pump with the filter attached, comes up here to the high pressure pump, camshaft rotates, so anytime the RPM changes, the pressure and volume of the pump also changes. Okay, and then it feeds over to our direct injection system. This one shows it on the side, so it can be either or. And then this would be our spark plug here. Low pressure supply pump, like we talked about. The pump in the tank supplies fuel to a high pressure pump. Pressure approximately 60 psi, so similar to what we've seen before. And then we have the high pressure pump, a range of anywhere between 500 at idle up to like almost 3,000 max. Again, very manufacturer and application specific. I know that they do go higher than that. Fuel rail. Again, fuel rail stores fuel from the high pressure pump. Stores high pressure fuel for use at each injector, similar to what we had before. have, electric pressure control, valve installed between the pump, inlet and outlet valves. Okay, so we can regulate, the pump. Use low pressure pump in the tank, similar to other fuel injection systems. PCM controls the high pressure pump using sensor inputs. So this kind of shows here, so typical direct system uses two pumps, one low pressure, one high pressure. This just kind of shows, kind of same information, but this is, one style of lobe on the camshaft. So as it turns, it pulses the pump. And again, this shows the camshaft. So we have our spring so that it stays in contact with the camshaft. We have this piston pumping all the fuel, and then our regulator to bleed it off if we need to, and the check valve to keep it from bleeding back. This is what one of the typical pressure units looks like. We do have a couple of engines, like I said, in the front of the classroom, the Subaru engine and the Ford V6 up there are both direct injection, so we'll probably look at those. We'll pull those two away from the wall so everybody can kind of gather around, and we'll kind of point to some of the components. But this is the fuel pump that we're looking at and looking for. And then, so this is the regulator to bleed it off if need be. And then we also have fuel pressure sensor. That's what we're going to be reading today. So how much pressure is in the rail available to the injectors based on pump speed. Each high pressure injector assembly is an electronically magnetic injector mounted in the cylinder head, similar to what we had before, but again, much heavier duty because of the amount of pressure. Okay. PCM controls each fuel injector with 50 to 90 volts, usually 60 to 70 depending on the system, which is created by a boost capacitor in the PCM. So we only have on, regular gasoline engines, 12 volts at rest and 14 volts at, when the vehicle's running typically. So now we have to boost the voltage to the injector, which diesels have done this for a long time, so that the injectors, open. So we need more voltage to control the injection system. Fords on their diesels had what they call the FICM, fuel injection control module, that would do this process for it. So we, voltage would go to PCM. PCM would boost the voltage up to all the injectors. And if it doesn't meet the minimum voltage levels to the injectors, then the injectors start failing. And it's not the fault of typically it's not the fault of the injectors, it's the module is no longer capable of boosting the voltage up. So different modes of operation. Stratified mode. In this mode, the air fuel mixture is richer around the spark plug than it is the rest of the cylinder. Okay, and then homogeneous air fuel mixture is the same throughout the cylinder. And then this just talks, variations of the different modes. And these are where it starts to get into some of the manufacturer specific stuff and how they want to, how they want to fire the injector, and some of the different, programming and mapping, where we start to see some of these differences. This is what's available. I won't get too far into it. As long as we understand injectors are different, it goes directly in the cylinder, has a high pressure pump, and some of those kind of things. We don't need to focus too much on this, like the spray strategy. These are the three most commonly designed piston tops. Okay, so spray guided combustion, swirl, and then tumble. This is just, different ways, again, of moving the air in and around where the fuel is and goes. And again, some of this stuff is manufacturer, some of the stuff that they get to decide how they wanna use it. So this is the spray guided, as you can see, kind of the way that the piston, is, kind of shaped right there in the middle, kind of keeps it, right there in the center, where the spark plug's going to be. So this is wall guided or swirl. So again, this one comes in from the side, and then again with piston, top design, kind of then, kind of swirls it around. As the air kind of comes in there, the air comes in one way and the fuel comes in the other way to swirl that way. And then the tumble, again, kind of similar in this one. But it all kind of depends on, valving and all of that. So just, if you understand that, stratified and homogeneous, those are the two main, primary modes of operation. And then there's some variance within both. Support and directed systems. So this is a combination of direct injected vehicles located in the combustion chamber, port fuel injection in the intake manifold near the intake valve. So these are systems that have both sets of fuel injectors. So on your sheet today, you need to identify if it's just direct injection with just one set of injectors, or if it's both. Toyota's the main one and has been doing this since the beginning with the extra fuel injectors, but other manufacturers do it as well, so we'll look for that today. Cold start and warm up to help reduce exhaust emissions after cold start. Fuel system uses stratified charge mode, and catalytic converter rapidly reaches operating temperature to reduce exhaust emissions. So catalytic converter efficiency is low when it's cold, and then so the quicker we can warm up the exhaust, the quicker we warm up the O2 sensor, we get feedback. The quicker we warm up the catalytic converter, the less emissions that we get. So notice there are conditions when port fuel injection located in the intake manifold and the gasoline direct injection located in the cylinder head both operate to provide proper fuel mixture. So low RPM and low engine speed source. So basically idling through the mid-range, we're gonna use a little bit of both. And then when we reach, high torque and high speed operation, then direct injection takes over only. Because we get more air velocity, moving through the intake manifold and everything, at higher speeds and higher RPM, we just use the direct injection only. Some of the issues, the injectors can often be heard with the engine running and the hood open, likely a normal condition. And carbon issues. Carbon issues have been big since these first started coming out. So carbon can accumulate on the tip of the injector. It can also accumulate on the backside of the intake valve. So one of the reasons that the port fuel injector exists is to make sure that the carbon doesn't happen on the back of the intake valve, or not as much. So this may become a drivability issue because gasoline direct injector is exposed to combustion carbon and fuel residue. Okay. The injector, this part of the injector is not, as much of an issue as the back of the intake valve, getting a sufficient amount of carbon on it. So carbon prevention, use of dispersant every 6 months or every 6,000 miles is proven to help prevent injector and valve deposits. Okay. Each manufacturer went about correcting this issue their own kind of way, but for the most part, a lot of times to clean this, the you would have to remove the intake manifold and in some way scrape all of the carbon off of the intake valve. One of the things that was popular was zip ties, and then putting them on a drill, so that the ends, basically, as you use the drill, would kind of fan out and then break up or chip away all the pieces of carbon. One of the things we also saw was broken pieces of like walnut shell, and then blasted under pressure at the carbon to kind of chip it away. So some different manufacturers did things differently. Again, it would be kind of manufacturer specific how you would kind of go about it. Some of the service precautions, we're not gonna reuse the high pressure lines. So from the injection rail to the injector themselves, and we'll see a picture of that in just a second. Always use torque wrench when tightening the fuel line fittings, okay, because we are dealing with high pressure. We need to make sure we don't have any leaks at all, okay? Don't loosen any fuel injection fittings when the engine is cranking or running, okay? And then always replace the Teflon seal whenever replacing or reinstalling an injector. So we'll see the injector in just a second. So this is an example of one of the fuel lines, okay? So whenever you take it off for any reason, every single time, it gets replaced. So it uses a ball and socket connection. The ball end deforms when the line is tightened. Why we need to use a scrub wrench to make sure it's tight enough. Okay? It must be replaced with a new part whenever it's removed. So as soon as you tighten that down, it deforms the end. Okay, so even if you make a mistake during the repair and have to take it right back off again, it's already deformed, okay, and can't be deformed again, okay. So whenever you tighten this to specification, you have to take it back off, get another one. And then on the end of the injector, this is what seals it in the cylinder head. There's a whole tool kit that helps you take these off and then reinstall them. So one of the engines that's in the classroom, these are fairly accessible from what I've been told. So we'll probably remove and replace the pump, and then remove and replace at least one of the injectors in the groups in the next couple weeks too. So whenever the injector is removed, there's special tools for that. But this seal, again, gets replaced every single time. Okay. So the line every single time, and then the seal. Okay. Any questions on the gasoline direct injection, the pump, the injectors? Okay. Again, we'll point out some of the components today, and then we'll look at some of the readings when we break into the lab. But the other thing we'll look at is the fuel pump current ramp on, I'll set that up on the Lexus. Questions on the front and the back, so 5 from chapter 81 and 5 from 81 on the back.